Good morning. Today we have discussed the problems related to probability and statistics. First, we have discussed the definition of random variable. Random variable is nothing but outcome of an experiment assigned a real number is called as a random variable. By proper definition, a random variable x takes on a defined set of values with different probabilities. For examples, if you roll a die, the outcome is random, not fixed, and there are six possible outcomes, each of which occur with the probability 1/6. Now, random variable classified in two different types. First one is discrete random variable. First, we had discussed the discrete. If x is a random variable which can take a finite number or countably infinite number of value, x is called a discrete random variable. When the random variable is discrete, the possible values of x may be assumed as x1, x2, etc. xn. Next, continuous random variable. If x is random variable which can take all values, that is infinite number of values in an interval, then x is called a continuous random variable. For examples, blood pressures. Blood pressures 80 to 120 lies between 80 to 120, like that only. Blood sugar 90 to 180, like that. This is a continuous random variable. Weight. Next, the speed of car, the real number from 1 to 6 is a continuous random variable. Examples. Next, probability function. Probability function may the possible values of x against the respective probabilities of occurrences is called P of x. P of x is a number from 0 to 1.
Hello, sir. Sir, you were muted, sir.
Thank you, ma. Thank you. Uniform distributions. A continuous random variable x with a parameter a and b is uniform if its probability density function f of x equal to 1 by b minus a, that is 1 by upper limit minus lower limit. Okay, this is a very important mean of the uniform distribution a plus b by 2. Variance b minus a the whole square divided by 12. Standard deviations, root of variance is called as the standard deviation. Okay, so standard deviation is equal to b minus a by root of 12. Moment generating function mx of t is equal to e to the power bt minus e to the power at divided by t into b minus a. Right. Next, exponential distribution. A continuous random variable capital X has exponential distribution if its probability density function capital small f of x equal to lambda e to the power minus lambda x is greater than 0, mean of the exponential distribution 1 by lambda, variance is equal to 1 by lambda square, and standard deviation is equal to 1 by lambda. Moment generating function mx of t is equal to lambda by lambda minus t. Next, last one, normal distributions. Probability density function of normal distribution f of x. It is a continuous case 1 by sigma root of 2 pi pi e to the power minus 1 by 2 into x minus mu divided by 2 the whole square. X varying from minus infinity to plus infinity, mu varying from minus infinity to plus infinity, and sigma is greater than 0. Moment generating function of normal distribution mx of t is equal to e to the power mu t, e to the power mu t plus t square sigma square by 2. Mean of the normal distribution mu. Expectation of x square is equal to mu square plus sigma square. Variance equal to sigma square. Okay, now that's all. Now come to problems. Now we have discussed the problems related to the only the gate questions. First one, a fair dice is rolled twice. Okay, fair dice. So what are the sample space here? Yes, 1, 2, 3, 4. Okay, here one the sample space is nothing but 1, 2, 3, 4. Right. So the sample space S is equal to 1, 2, 3, 4, 5, 6. The sixth sample, so S equal to 6. Here, probability that an odd number will follow an even number. What is the odd number? 1. 1 is the odd number, 3 is the odd number, 5 is the odd number. So totally 3 odd number is given out of 6. So the probability of odd number equal to 3 by 6. After simplification, we get 1 by 2. Similarly, even number 2, 4, 6. So how many? 3 even number. So 3 out of 6 even number, 3 by 6. After simplification, we get 1 by 2. So probability of odd given by even, followed by even, followed by even, already even is happened. Next then odd functions by the conditional probability. Here even and or are independent. Therefore, P of A given B is equal to P of A into B. Therefore, P of odd given even is equal to 1 by 2 P of A into 1 by 2 P of B. So 1 by 2 into 1 by 2 is equal to 1 by 4. So answer is equal to 1 by 4. Now, the probability density function of function f of x is given. So this is P of always generally in a continuous case is generally is denoted by f of x. But here what is given? P of x is given. But anyway, what is the limit? X belongs to minus infinity to plus infinity. X varying from minus infinity to plus infinity. Find the values of k. Okay, once again, in a continuous random variable, first basics. In a continuous random variable, x by the definition minus infinity to plus infinity. Minus infinity to plus infinity, f of x dx is equal to 1 in a continuous case. In a discrete case, summation of p of x is equal to 1 by the total conditions. Here what is given? Integral over minus infinity to plus infinity f of x dx equal to 1. What is the f of x? Here f of x equal to k e to the power minus alpha into modulus of x. K e to the power minus alpha modulus of x into dx is equal to 1. Why? See, read the questions. Probability density function clearly given. A probability density function of the random variable is given. So it is a continuous case. Therefore, integral over varying from minus infinity to plus infinity k e to the power minus alpha modulus of x into dx. Here, the integration having two different methods. Now we will discuss first a simple method. Okay, so x is odd function. Okay, modulus of x is even function. So we have already studied in the lower class integral over minus a to plus a, integral over minus a to plus a, f of x into dx, f of x into dx. So f of x odd function mean 0. F of x even function mean 2 times integral over 0 to a f of x into dx. It can be written as 2 times integral over 0. The lower limit becomes 0. 0 to a, 2 times 0 to a f of x dx. Now, this is a even function. Okay, so e to the power minus modulus of x is given. It is a even function. So, applying the formula integral over 2 times 0 to infinity. Integral over 0 to infinity. K also constant. Take outside. E to the power minus modulus of x. E to the power alpha minus modulus of x into dx is equal to 1. So 2 into k, integral of e to the power alpha, e to the power, okay, sorry, once again. So after applying the properties, 2 times integral over 0 to infinity mean minus alpha, no need modulus value, just x only, into dx is equal to 1. So 2k, what is the e to the power alpha x? E to the power minus alpha x. E to the power minus alpha x divided by minus alpha. So limit is equal to 0 to infinity is equal to 1. So 2k, first put in the upper limit. E to the power minus infinity 0 minus e power 0 1 divided by minus alpha. 1 divided by minus alpha is equal to 1. So minus become plus. So 2k by alpha. 2k by alpha is equal to 1. So 2k is equal to alpha. So k is equal to alpha by 2. Alpha by 2. Now what is given? Please read the option. Here 0 0.5, 1.5 alpha. So 1 by 2 is nothing but 0.5 only. Okay. Therefore 1 by 2 alpha is equal to 0.5 alpha. So option C is the correct answer. But here what is given? Here here integration's different mode is given, that is minus infinity to plus infinity k e to the power minus alpha x can be written as, so minus infinity to plus infinity. So minus infinity to 0, x become negative value. 0 to infinity x become positive value. So that is minus infinity to 0 k e to the power minus x. What is here? Minus x. So minus of minus become plus k e to the power alpha x dx. Integral over 0 to infinity k e to the power minus here plus x. So and then integrate, we get same answer only. Okay. Now we get the same answer. Now this is the base theorems. Three companies X, Y, Z supply the computer to the university. Next, third questions. Three companies X, Y, Z supply the computer to the university. The percentage of computers supplied by them and the probability those being defective are tabulated given below. So the X, computer X, supplied by 60%, here probability of defective item is equal to 0.01. Next, the Y, computers supplied 30%, here probability of defective item is equal to 0.02. Here Z is equal to 10%, probability of defective item will be 0.03%. Given that the computer is defective, okay, the probability that it was supplied by A, the probability that it's supplied by Y, that is the problems questions. Now, 1 minute. Right. Now solve the problems. Here, this is the X computer. So P of X, probability of X is equal to 60%. 60%, that is 60 by 100. Okay. Here now we have problems without using calculator. We have simplification by using without as calculator. Okay. Next, P of Y. So the computer Y, probability of Y is equal to how much? How many? 30% sub. So 30% by 100. 30 by 100. Next, C, probability of Z. So probability of Z computer supplied is equal to the computer supplied by Z equal to 10%. That is 10 by 100. 10 by 100. Okay. Next, let capital D be the defective items. Let K be the defective items, probability of defective items. That is, now what is given? Probability of defective item A. So the probability of defective by A, defective by A is equal to what is given? 0.01. So 0.01. For our convenience, this can be written as 1 by 100. Next, so probability of defective item supplied by this is X, sorry, X. This will be Y. Probability of defective item by computer Y is equal to 2%, 0.02. So this can be written as for our convenience 2 by 100. 2 by 100. Next, so probability of defective item manufacturing by third one is Z is equal to 3%, 0.03. That is equal to 3 by 100. 3 by 100. Okay. Now, what is the questions? Given that the computer defective, the probability of defective will be white. Oh, sorry, Y. Yeah. Okay. So the probability it was supplied by Y. Supplied by Y. What is the formula? By the base theorems. So probability of Y. The probability of computer came from Y. It will be defective item. Y by D is equal to, okay. So P of D by Y. P of either Y. So P of Y into P of d by y, d by y divided by total probability. Similarly, same thing. So like P of x. So P of x into P of d by x. P of d by x. So d by x plus P of y. So P of y into P of d by y. P of d by y plus P of z. So P of z into P of d by z. This is the Bayes theorem. Now, what is the P of y? P of y is equal to 30 by 100. Okay, simplification is very easy, sir. So 30 by 100, 30 by, oh sorry, is equal to 30 by 100 into P of d by y. So what is the P of d by y? 2 by 100. So
Sir, sir, you have been muted, sir.
okay, into 1 by 100 plus next one P of y 30 by 100. So 30 by 100 30 by 100 into, so 2 by 100, 2 by 100 plus P of Z. What's a P of Y? Is a 10 by 100. Okay, 10 by 100. Very simple. Simplification is very simple, sir. 10 by 100 into 3 by 100. So 3 by 100. Now take common. So 1 by 10,000 is taking common. What will be happen? 10,000, 10,000, 10,000, 100 into 100, 100 into 100, 100 into 100. So 1 by 10,000 is taking common. So the numerator 30 into 2, 60. 30 into 2, 60. Divided by 60 into 1, 60. Plus 30 into 2, 60. Plus 3 into 10, 30. 3 into 10, 30 is equal to 60. 60 divided by 6 plus 6, 120, 150. So 150. 0, 0 cancelled. 6 by 15. 6 by 15. This is the answer. Okay, 6 by 15. What is the answer? 6 by 60 D. Or after simplification, how can get 6 15? Once again. 6 by 15 is equal to 15. 6.0. So 4 into 15, 60. So 0.4. Answer is equal to 0.4. Okay, answer equal to 0.4. Okay. Any doubt? Now, so fourth one, very simple problem, sir. If E denote the expectation, the variance of random variable x is given by, now only discuss the formula E of x square, the variance equal to E of x square minus E of x, E of x the whole square, the variance formula E of x square minus E of x the whole square is called the variance formula. Once again. Okay. Next. Okay. Come to problem 5. This is also most repeated. An examination consisting of two papers, paper 1 and paper 2. The probability of failing in paper 1 is 0.3. Okay, this is the conditional probability. Now we will discuss later the problems. Now probability like conditional probability we will discuss next class. Okay. Next, P of x is given. So m exp is nothing but e to the power minus 2 modulus of x. Okay. Minus n into e power minus 3 modulus of x is the probability density function. Probability density function mean continuous random variable. Clear? Okay. Probability mass function mean discrete random variable. Here clearly given density function. But density function generally denoted by f of x, but here given p of x, no problem. But given statement density function for the real random variable x over the entry x axis. M and n both are positive real number, then the relating n and m is, what is the relation between m and n? Now, once again, please. Okay. Next, on to problems. Now, what is the probability density function? That probability density function is given by, once again, I take the problems. So it is the continuous random variable clearly given, continuous random variable. Therefore, first conditions f of x. F of x is should be greater than 0 and then integral over minus infinity to plus infinity f of x. F of x into dx. F of x into dx is equal to 1. Okay. Because here clearly given it is the probability density function. So it is the positive value. Integral over minus infinity to plus infinity. So m into e to the power minus 2 modulus of x. 2 modulus of x into dx. Now applying the linearities, that is separated. Integral over minus infinity to plus infinity. So n into e to the power minus 3 modulus of x into dx into dx is equal to 1. Okay. Now here, so 2 modulus of x is given. E to the power minus modulus of x is given. Modulus of x means it is a, definitely it is a even functions. Okay. So 2 times m is constant, take outside, m is take outside, integral over 0 to infinity, integral over 0 to infinity, e to the power minus 2x, no need modulus value, e to the power 2x into dx. Once again, I check that. Okay. Minus integral over, same thing, 2 times n is take outside, so 0 to infinity, 0 to infinity, e to the power minus 3x, no need modulus value, into dx is equal to 1. Now integrate, so 2m, so 2m, so integral of e to the power minus 2x, e to the power minus 2x divided by minus 2, 0 to infinity, 0 to infinity minus, so 2 y n, okay, minus 2n, minus 2n, So integral of e to the power minus 3x, e to the power minus 3x divided by minus 3 is equal to 1, 0 to infinity. First put in the upper limit. So 2m, so 2m into, what is the upper limit? E to the power minus infinity 0 minus e power 0 1, 1 by minus 2 minus 2n. Same thing, first put in upper limit e to the power minus infinity 0 minus 1 by minus 3 is equal to 1. So minus minus cancel, minus minus cancel. So 2m minus 2n by 3 is equal to 1. 2m by 2, 2 cancel. So m is equal to 1. So minus 2n by 3, bring the right hand side, what will be happen? Plus 2n by 3. 2n by 3. So the m is equal to 1 plus 2n by 3. This is the answer. Yes. M. Here, what is the option is given? Yes. M. The first one is correct answer. Correct only. Yes. Next one. Now we will discuss probability. We will discuss next class. Okay. Similarly, now come to next problems. Consider the continuous random variable with probability density function is given 1 plus t, varying from minus 1 less than t less than 0, 1 minus t varying from 0 to 0 less than t less than 1. The standard deviation of the random variable. Standard deviation of the random variable. One second. Right. Okay. So what is f of t? F of t is equal to given two ranges. The first one, standard deviations. First find the variance. What is the formula? Variance of x is equal to e of x square, e of x square, expectation of x square minus expectation of x the whole square, expectation of x the whole square. First find e of x, expectation of x. Here x by what is given? Dummy variable t given, that's all only. So what is the formula e of x? In a discrete case, e of x equal to summation of x into p of x. In a continuous case, integral over x into p f of x into dx, the expectation of x. Here the expectation of t is given. Here the function given two different arrays. The first one is equal to minus 1 to 0, minus 1 to 0, t into 1 plus t, t into 1 plus t into dt plus integral over 0 to 1, integral over 0 to 1, 1 minus t, 1 minus t into dt, 1 minus t into dt. Now is simplified, is equal to t into 1, so t into t square, integral over minus 1 to 0 t plus t into t square into dt plus the second one, integral over 0 to 1. So t, here t is missing, sorry, t minus t into t square into dt. Now integrate, integral of t is equal to t square by 2 minus, sorry, plus integral of t square t cube by 3, t cube by 3. The limit varying from minus 1 to 0 plus integral of t t square by 2. T square by 2 minus t to the power 3. T to the power 3 divided by 3. So what is 0 to 1?
Good morning, sir.
Yes, ma'am. What, ma'am? Please meet, ma'am. 43. Meet your audio. 43. Please meet your audio. 1 second. Thank you. 1 second. Okay, now put in upper limit. 0. What is 0? 0 plus 0 minus lower limit minus 1. Minus 1 the whole square. 1. So 1 by 2 plus minus 1 to the power 3. Minus 1 to the power 3 is minus. Okay, minus 1 by 3. The first function. Now come to second function. 1. 1 by 2. 1 by 2 minus 1 by 3. 1 cube also 1 by 3. So the lower limit will be 0. Now is equal to minus 1 by 2. Okay. Multiplying by minus sign. So minus into minus plus 1 by 3 plus 1 by 3. Next plus 1 by 2 minus 1 by 3. What will be happen? 1 by 2, 1 by 2, 1 by 3, 1 by 3 cancel. Therefore 0. Mean is equal to 0. Okay. Now next to find variance. Let's find second moment about the second moment. What is the form of second moment? Expectation of x square. Expectation of x square is equal to, in a discrete case, e of x square p of x. In a continuous case, integral of x square f of x into dx. Okay. Now, so e of x square, that is here t square only, because here variable is t only. So integral over minus 1 to 0 t square into 1 plus t into dt. Next plus integral over 0 to 1 t square into 1 minus t into dt. Now integrate. Before integrate, simplify. Integral minus 1 to 0 t square into 1 t square plus t square into t cube into dt plus integral 0 to 1. Again same thing, t square into 1 t square minus t square into t cube into dt. Very simple. This is your gate question, sir. Okay. Now upper limits. In the first integrate. Integral of t square t cube by 3. Integral of t square t cube by 3 plus t cube t to the power 4 by 4 minus 1 0 plus again same thing t square t cube by 3 minus t to the power 4 by 4. Put in upper and lower limit. First upper limit will be 0. 0 into anything, 0 only. Now lower limit minus 1. Minus 1 to the power 3 minus 1 by 3 minus 1 to the power 4 plus 1 power 4. Next plus 1 cube. Okay. Here also 0 to 1 only. Okay. First put 1 by 3 minus 1 by 4. The minus is taking common, take inside minus plus minus. So 1 by 3 that is what is plus 1 by 3 minus 1 by 4 plus 1 by 3 minus 1 by 4. Okay, what will be happen? 1 by 3 2 times 1 by 3 2 times 1 by 3 1 by 4 2 times 1 by 4. Now LCM 4 into 2 8 minus 3 into 2 6 divided by 3 4s are 12. 8 minus 6 equal to 2 by 12. After simplification we get 1 by 6. What is the formula? variance of x. Variance of x is equal to expectation of x square. Expectation of x square minus expectation of x. Expectation of x the whole square. E of x square. E of x square 1 by 6. 1 by 6. E of x equal to 0. 0 square equal to 0 only. Now 1 by 6. Variance of x 1 by 2. The standard deviation is nothing but root of variance of x. So root of variance of x. Root of variance of x is equal to 1 by root of 6. This is the variance of a given function. Okay, option equal to, but here given directly given, okay, this 1 by root of 6. See, but this is not necessary. We have given lot of formats, but not necessary. The standard deviation of a uniform distributed random variable between 0 and 1. What's the formula? Standard deviation. First, mean of the binomial distribution E of x is equal to a plus b by 2. A plus b by 2. Variance of x. Variance of x is equal to b minus a. b minus a the whole square. b minus a the whole square divided by 12. Now, what is the problems given? 0 to 1. F of x, the uniform distribution vary from 0 to 1. So 0 less than or equal to x less than or equal to 1. Like a less than or equal to x less than or equal to 1. Variance equal to b minus a. B equal to what? 1 only. Okay, here b is equal to 1. 1 minus 0 the whole square. 1 minus 0 the whole square by 12 is equal to 1 by 12. So variance of the uniform distribution 1 by 12. So what is given? Standard deviation. Find the standard deviation. So variance, root of variance of x. Okay, standard deviation SD is nothing but root of variance of x, that is root of 1 by 12 is equal to 1 by root of 12. 1 by root of 12. This is a standard deviation. Okay. Now, similarly, okay, now we will discuss the probability later. Okay. This is your probability problems. Okay. I will take another one of the problems. Please wait. Okay. 1 minute. Okay. So problems given here. This is also your university questions. A random variable. Okay. So problem. This is your. One second. Okay. The question is given in the probability density function of random variable capital X, f of x. The probability density function f of x equal to x square, f of x equal to x square minus 1 less than or equal to x less than or equal to 1. Clear? Otherwise 0. Find the percentage of the probability, but probability function varying from -1 to +1. Yes, it is the even function. But what is the questions? Then the percentage of the probability. So P of 1 by 3 minus 1 by 3. P of minus 1 by 3 less than or equal to x less than or is equal to 1 by 3. This is the find the percentage of the probability. Okay. Now this is simple only. Now integral over minus 1 by 3 to plus 1 by 3 f of x. What is f of x given? X square. X square into dx. X square into dx. This is a even function. Therefore 2 times integral over 0 to 1 by 3. Integral over 0 to 1 by 3 x square into dx. X square into dx is equal to 2 times integral of x square. What is the value of integral of x square? Sorry. Integral of x square is nothing but x cube by 3, x cube by 3, 0 to 1 by 3 is equal to 2 by 3. So 3 is taking outside, replace x by 1 by 3. So 1 by 3 cube, 3 3s are 9, 9 3s are 27. 1 by 27 is equal to 2 into 1, 2, 3 into 27, 81. What is the problem? What is the percentage of the probability? What percentage of the probability means 2 by 81? So 2 by 81 into 100 percentage. 100 percentage. That is 200. So 200 by 81 percentage. 200 by 81. After simplification, we get 81. So 81, 200. Sorry. So 281. So 2 times 2 into 8, 16, 162, 162. So after simplification, 8, 3, 38. So put 0.0. Okay. 8, 8 here, 3. So 38. So 380. So 4 8s are 30. So 2.4 something. So the answer will be 2.4 something. Next, similarly, same problems, like the same problem, a continuous random variable f of x, a continuous random, this is also your gate problems, f of x is equal to x by 4, x by 4, x by 4 into 4 minus x square, 4 minus x square in 0, 0 less than or equal to x less than or equal to 2. Find the mean of, that is, find the mean either mu sufficient x. Mu sufficient x is nothing but mean of the random variable. What is the, suppose expectation of x is called mean. In case discrete mean summation of x into p of x. Discrete mean summation of x into p of x. Continuous mean integral over minus infinity to plus infinity f of x, minus infinity to plus infinity f of x into dx. Now this is a continuous case. So expectation of x, mean of x, e of x is equal to integral over, sorry. So integral over, what is the function? 0 to 2. So 0 to 2, integral over 0 to 2 x, x into f of x. What is the f of x? X by 4. X by 4 into 4 minus x square. 4 minus x square into dx is equal to integral over 0 to 2 x into x. So 1 by 4 is take outside because of constant x into x. What is the value of x into x? X square. X square into 4. 4x square minus x square into x square. X to the power 4 into dx. Now is equal to 1 by 4. 1 by 4 after integration. 4x square. What is the 4x square? 4x cube by 3. 4x cube by 3 minus x to the power 4 is nothing but x to the power 5 by 5. 0 to 2 is equal to 1 by 4 is equal to 1 by 4. Applying the limit 2 cube, 2 into 2, 4, 4 into 2, 8. 8 into 4, 32. So 32 by 3 minus 2 to the power 5. 2 to the power 5 is equal to what, sir? 2, yes, like that, 32. 32 by 5. 32 by 5. Now simplification is equal to 1 by, okay. Now 4 is take inside. So 8 into 4. 32 can be written as 8 into 4 divided by 4 into 3. 4 into 3 minus, similarly, 8 into 4. 8 into 4 divided by 4 into 5. 4, 4, 4, 4 cancel is equal to 8 by 3. 8 by 3 minus 8 by 5. Simplify 5 into 8 are 40 minus 3 into 8, 24. 24 by 15. 40 minus 24 is equal to 16 by 15. 16 divided by 15. Therefore, the probability mean of the random variable is nothing but 16. 16 by 15. Okay. Next is similarly one more problem is given by f of x equal to 0.25. Okay, the probability density function f of x equal to also you also get questions, sir. So 1 less than or equal to x less than or is equal to 5. The function varying from 0 to 5. But problem is nothing but find p of x less than 4. X less than or is equal to 4 below. So that is integral over what is the lower limit? 1. 1. What is the upper limit? 4. Here 4 less than 4. We have to calculate only the less than 4 value of less than 4. F of x 0.25. 0.25 into dx. 0.25 is constant, take outside. Integral of dx is nothing but x. So 1, 4. So 0.25. 0.25 upper limit 4 minus 1 is equal to 0.25. 4 minus 1 is nothing but 3. So 0.5 is nothing but 1 by 4. Clear? So 1 by 4 is equal to 3 by 4. The option is 3 by 4. The probability density function of that is probability of p of x less than or is equal to 4 is nothing but 3 by 4. This is the problem answer. We have lot of problems given like okay. Now next problems like problems probability like that. Okay. Once again. See. Read the question 32. X and y be the two independent random variable. Which one of the following relation be expectation E of x and variance of x and covariance of x is given below is false. Okay, this is a E of x y equal to E of x into E of y. That is the correct statement. When x and y is even, when x and y is independent, means E of x y equal to E of x into E of y. Next, covariant of xy equal to 0. Covariant of xy is equal to 0. Next, variance of x plus y equal to variance of x plus variance of y. Next, E of x square y. Okay, this is cut only. Okay, option covariant of xy is equal to what is the covariant of xy? Covariant of xy equal to E of xy minus E of x into E of y. Okay, like this. Okay, students. Next, yes, correlations. Right. Next problem. One second. Yes. This only now only we have discussed this problem only. No. F of x equal to x square minus 1 to plus 1. 0. Find the percentage of the probability minus 1 by 32 plus 1 by 3. After simplification, we get 2.47. Next. This is the normal distributions. So next we have discussed the normal distributions. Okay. Wait. Yes. This is okay. Come to next one. X is uniformly distributed random variable between 0 and 1. Then the value of x cube. Okay, first find the probability density function f of x equal to upper limit minus lower limit 1 by 1 minus 0, 1. Okay, probability density function is nothing but 1. E of x cube, expectation of x cube is nothing but integral over 0 to 1 x cube into f of x. What is f of x? 1. So into dx, integral of x cube, integral of x cube, x to the power 4 by 4. Integral of x cube, x to the power 4 by 4, 0 to 1. So put in upper limit 1 by 4 minus lower limit 0. answer is equal to 1 by 4. Okay. Okay, students. Okay, wait. Thank you, students. Thank you. Students, please leave the meeting. Thank you for
Thank you, sir.